let's reconsider the hot air balloon problem from the homework. This one has vertical distance that changes, while it's also traveling along a horizontal axis. So we have to consider the vertical rate of change, 50 feet per minute. So every minute that goes by, the balloon that starts off on the ground, obviously, is creeping upward. Actually, it's going pretty fast. 50 feet per minute is pretty steep, right? So every minute that goes by, another 50 feet, another 50 feet, another 50 feet. The entire journey lasts 20 minutes. So that means it comes back to ground after 20 minutes. So at some point it's going to stop and come back down and land on the ground like that. And this tracks the height. We need an equation for the height in terms of minutes. So that looks like h of t means the height in terms of minutes is what? How are we going to calculate the height of the balloon? Okay, well, let's think about this. Since the rate is 50, if we know the time, we basically just take, remember, distance is equal to rate times time. That applies to vertical distance also. So however much time has gone by, we just multiply by 50 and we find out how high up in the air the balloon is. Sort of. It gets higher and higher and higher, but what happens after this point? When it starts coming back down, the time has increased, but the height has decreased. So this is going to be a little more complicated than just rate times time. Somehow, we have to get the distance, that vertical distance, to increase and increase and increase until it gets here, and then decrease, 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 all the way back down to 0. So this is related to the endpoint problems that we did previously. We want to multiply our rate by how far we are from 0 or how far we are from 20 minutes, which is the end of the ride. They are an exact mirror image. So you can imagine folding this in half and turning it into just one right triangle that could represent the entire trip. Here's 0 or 20. Here's the halfway point, which appears to be at 10 minutes. So as the time increases all the way to 10, remember we just want to multiply by 50, then at 20 it's the same as 0. We should have a height of 0. At 19 it's just like 1. We should have a height of 50. And then 18 is like 2. 17 is like 3. It is a mirror image. So what we really want to do is multiply that rate times how far we are from either endpoint. So let's set it up just like we set up the other endpoint problems. Remember that we first found the distance from the center. In this case, it's the amount of time from the middle time. So we take our time minus the middle time, which is 10 minutes, and then do absolute value because we don't know if our time is less or more than 10. That gives us a time away from the center, but we don't want that. We want distance from the endpoints. So we again take half the time and subtract the distance from the middle to get the distance from the nearest endpoint. This isn't really distance though, this is time from either the beginning time or the ending time. In order to get distance that we've gone up in the air, we then take that amount of time and multiply it by the rate. So now we've got our rate times our time, which equals distance. Now that's not the only way to solve this problem, so I'm going to go over a completely different way to get the equation using the vertex. In any of these absolute value problems with two variables, if you can find the vertex and you know the rate, then you can write the equation. We know the rate is 50. We also see the picture that a balloon is going to go upward and then downward. And so we call this a downward absolute value graph. And so the rate is actually going to give us a negative value in order to get this. So let's see what we've got. H of t is equal to negative 50 times t minus, I'll leave a blank there, plus the maximum y value. So in this case, this is the horizontal shift, and we always use the opposite, and this is going to be the vertical shift, or the maximum height that the balloon reaches. And we don't use the opposite because it's already been moved to the other side away from h. So let's see if we can find this out. Now it would appear that this balloon reaches the maximum height at the halfway point so that it comes back down to the ground at 20 minutes. So what is the maximum height? It looks like for a t-value of 10 minutes, we get to the maximum height. So let's think about this. If the balloon is rising 50 feet every minute and 10 minutes have gone by, then 10 times 50 is 500, and so 500 feet is probably the maximum, right? So let's assume that this is the vertex and see what we get. For the horizontal shift, we would use minus 10, and for the vertical shift, we're going to use plus 500. And that's our equation using the vertex and the rate and the parent graph that normally goes up, but this one goes down, so we put a negative out in front. Now compare that to the other equation we got. They look really different, don't they? So now I'm going to use some algebra to prove that one of them is actually the same as the other. Let's start with the first equation and see if we can do some simplifying. Okay, if I multiply the 50 into those parentheses, I get 500 minus 50 times t minus 10. Now what do you think? That looks a lot more like our equation, right? The only difference is that this term and this term have been written in a different order in my second equation. So if we move those around, we get negative 50 times t minus 10 plus 500. And now the two equations are exactly the same. So there's two approaches that are very different. Either approach comes out with the right answer. That gives you two tools to put in your toolbox to solve problems like this.